In this video, we're going to talk about finding the perimeter of our algebra tiles when they're grouped together like they are shown in problem 3 and 4 here, and how we can take those perimeters and write them as algebraic expressions. So if we take a look at problem number 3, the first thing I like to do when I'm looking at perimeter is actually to label all the different parts. As we discovered before, the side lengths of our big X squared are all lengths of X. So I'm going to write that as I move around my figure. And I labeled all the sides that had a side length of X. Now, the next ones I have a side length of are these little pieces right here, which we also discovered those are side lengths of 1. Notice I'm only labeling the things on the outside of the figure. If they're lines on the inside, that's not part of our perimeter. Perimeter is only the surrounding sides that are on the outside of the figure that we have. So now that I've labeled all this, I can actually start writing my algebraic expression. In this case, my perimeter, and I'm going to write it in simplified form, so I'm going to talk about all the different parts I have together. So I have X's that I want to talk about first. So my perimeter here, I have 1, 2, 3, 4, 5, 6 X's. And I have 1, 2, 3, 4, 5, 6 1's. So that would be the expression that I would write for this perimeter. When we get to perimeter for problem 4, it gets a little bit more challenging, and you'll see why in a moment. So I'm going to write all my different side lengths as I move around the figure again. And I'll note that I'm only ever having side lengths of X or 1. The reason why these have X squared written on the inside is because that's related to the area where we actually did some multiplication. Now I'm going to show you guys which part of this gets a little bit tricky. When we look at this side length here, we know that this side length is a side length of X, but there's little parts that are actually cut off of it. We have one right here that is cut off, and we have one right there that is cut off. So really, that's going to be tricky when we get to it. I'm going to start by saying the stuff I do know. I know that I have 1, 2, 3 full X's here. So I have 3 X's, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1's. So this represents the stuff that I know I have completely. Well, now I get to this piece right here. I know that this is a side length of X, but I really have to get rid of this one right here and this one right here. So to show that I'm getting rid of them, I'm going to really add the X to this problem, but then I'm going to subtract side lengths of 2 because I have to get rid of this one and this one from my total. So I could say that the perimeter of this figure is 3x plus 10 plus x minus 2 because of these two parts right here. Well, this isn't completely simplified yet. I could also write it as I have 4 x's total, and, well, 10 minus 2, I only have 8 1's. So there are two different ways we could kind of look at it. But this was a trickier problem because we had to get rid of these parts from our perimeter because it did not have that total side length of X. All right, thank you guys for watching the video. I hope this helps.